Crunch Labs recently released their second hack pack, a domino robot. You fill the robot with dominoes by pulling back a plastic piece held closed by a repurposed badge holder. When it hits the switch, it'll stop and you can refill it and then restart it. It can also use these light sensors to follow either a black or white electrical tape line to create some sort of pattern. My 4-year-old son loves playing with this thing, and he will play with it without me. He can even load the dominoes, so you can't tell me it's too delicate. He does need a lesson on how to knock the dominoes over though, because the flick it as hard as you can method isn't quite working out for him. Crunch Labs has a lot of pieces for this available to 3D print, including printing even more dominoes. The dominoes are also 48 by 24 by 8 millimeters, and you can find some on Amazon like the ones I have linked below that I've been using. Before we get started, Crunch Labs does have a Discord you can join, which contains a huge community and a ton of troubleshooting support as well. Everything except the tape and dominoes come in bags that are relatively easy to open and separated by type of part. Make sure you have all your parts and there's no damage before you begin building. Crunch Labs will send you new parts as necessary if you have problems. First, we'll take half of the domino slide, cap one end, and insert a metal rod through the holes. Slide in the box that moves the dominoes and cap the other side. The stop switch is attached to the side of a frame piece with 2 screws. Always check your work against the pictures in the booklet. Attach both parts we've made so far with 2 screws through the center. You can use a 4mm Allen wrench to help you with the screws. We're going to sandwich the servo board we just made between a support and half of the domino slide with a few pulls and screws. I recommend a 4mm Allen wrench here too for these screws. We're going to attach both the frame pieces we've made together in the front with another longer pole and 2 more screws. Next we'll make the slider which dispenses the dominoes. Make sure the plastic piece faces the right direction and always verify against the pictures in the booklet. Next, we'll connect the back of the frame with the dispenser piece we just built. Screw in both reflective light sensors to their mounts. Direction does matter, so use the pictures and wire colors as reference. Be sure to use a plastic washer on the screws so you don't cause any electrical problems. With our light sensors mounted, we will screw in the mount to the frame. The picture shows a tab behind the mount which is missing on my piece, but it's okay and works just fine. Continue with the instructions to attach a pad and supports to this top plate. Insert the Arduino into the breadboard with the USB port facing away from the power strip. Stick that breadboard to the top of the toppiest plate with the USB port facing backwards. Connect the light sensors to the breadboard. Take note that the green and blue wires have a color-coordinated hole in that breadboard. Slide in the battery pack and plug the USB cable into both the battery and the breadboard. The servo has an orange wire and the stop switch has a yellow wire, which are each color-coded and should be connected to the breadboard. The motor driver board slots right into the breadboard, and it's very important you match the orientation shown in the booklet. Next, we'll screw in both wheel motors and wire them to the driver board. The pins you connect to are important, or your robot will be going the wrong way. The string we're attaching will pull the square towards the end as dominoes are dispensed, and will eventually trigger the stop switch when it's empty. Finally, load some dominoes and first try it in a straight line. Once that works, try some black tape on a light surface. If it doesn't follow the tape, double check for loose connections on the breadboard. I've had my wires loose and it didn't follow the line at all. Here we are again in the CrunchLabs Web IDE, and just like with the IR turret, we have access to a video, serial output, mark robot to help troubleshooting, different levels of code, and different code examples. I didn't choose purple on gray, and I don't see a way to change it, so bear with me here. Our stock code that the Arduino came with is here. It looks like we start by importing a few libraries and defining some variables. But I wouldn't suggest changing anything except top speed and dispense distance. We also have a lot more variables being created here, and thankfully, every line is commented. Our setup method creates a servo that dispenses dominoes and initializes the stop switch, which is engaged when we run out of dominoes. Finally, we have an 800 millisecond delay before it starts moving. Our loop first calculates the value between both sensors following a line, and then slows the appropriate motor to turn the device. Using the combined motor speed, we'll dispense a domino when an appropriate distance has passed. If our stop switch is engaged, we'll stop moving and stop dispensing. Other examples include auto knockdown, which when it runs out of dominoes, it will turn around and knock them over. The line racer example doesn't dispense any dominoes, but it will try to go as fast as it can in a straight line. Finally, the IR remote example uses the code from the first HackPack turret so you can control it and press 2 to enable race mode and press 1 to disable. So first, what I liked. The IR turret had an issue where if you rotated the pitch servo, it could be in an orientation that causes it to overheat because it can't home into the correct position. Very likely that's user error, my fault, but I haven't run into this similar issue with the Domino robot. It's also less effort to reset when reloading the dominoes. The IR turret darts was a lot of effort, and it showed with the kids. I would reload it, they would play with it, they'd fire the darts, and then they'd move on to other things because it was hard. With the Domino robot, they'll lay the dominoes, knock them over, and want to put more in. It has some cool ideas like the badge holder pulling in the dominoes towards the back of the device. The way the servo moves, the plastic dispenser to dispense the dominoes, and using multiple light sensors to determine which direction the robot should turn. What I didn't like, I think this one was a little more difficult to assemble than the IR turret since the wires seem to be easily pulled out of the breadboard and some of the screws aren't accessible with fingertip. I had a 4mm Allen wrench on hand to help me with that, and the instructions could have been labeled with numbers so that you twist the cylinder onto the screw. And also sometimes dominoes will get hung up on the dispenser in the back. It happens, it's not a big deal since it's moving away from the already laid dominoes, but you will have to fix the occasional domino. Overall, I think this is a good little learner's robot from Crunch Labs. These are expensive per robot, but they don't come with an off-brand Arduino. It's an actual Arduino Nano, a unique breadboard with a power switch that I haven't been able to find anywhere else, and a battery pack that I may just toss in a bag if I think I'm going to need a power bank. It also has a ton of support, including the stencil files you can download to 3D print for replacement parts and more dominoes, an active Discord where Crunch Labs employee themselves can help you troubleshoot or encourage your builds. I'm happy with what I got, and after my videos, I disassemble it and rebuild it with my kids before filming their parts. It's worth it to me, and probably to you too, if and only if you want to run with it, continue to build on it, hack it, and go farther than what Crunch Labs gives you. It may not be worth the price to somebody who just wants to build it, play with it for an hour, and then shelve it, but that's not the point of the subscription, is it?
Need more dominoes.
Maybe one more?
How much did you say?
Okay, so now you turn it on.
Okay, I'll put these two dominoes back. Okay. And go. I made it longer than I expected. Make sure it doesn't mess up.
You gonna knock it over now?
Okay. I want to add more.